these smoke machines, and then I wanted to make it completely portable. And I have one of these, just got for free. So I'm gonna get this motor and put it into this for the input to get a regulated flow of smoke portable. So I bought this unit before reading the reviews, and there are a couple problems. They have like the cap melting, and then something inside where the hose melts and then leaks all the oil, the 10 to 20 milliliters of oil out to the bottom, getting everywhere. Let's take a look. Really, this thing only has one setting. There's a switch. There is no circuitry. I'm assuming this is probably a cutoff. It's very poorly installed. It's not even touching. We'll probably fix that. That's probably what protects the overheating. The heating element seems to be right here. So looking right here, there's the culprit. That's what melts. That's this tube here. At least that's what the comments say, or the reviews. It seems... Yeah, that's probably not silicone or high-tech tube. I'm gonna fix this. Naturally, this wants to be pulled like that, so that means this zip tie over here is causing a lot of pressure on the wire, which is why the adhesive ripped right there. Not ripped, but got peeled off. I'll probably use some Kapton tape or something rather than this. And maybe we can put some thermal paste on this as well. Don't know if you need to, but I will. We actually got a part number. KSD 9700. It's a 5 amp. I think a better position for the switch would be right here on this groove. It seems to be the exact size for it. That's where we're gonna put it. Again, we're gonna unscrew that, untying that zip tie, because it's putting a lot of pressure on the switch itself. It does not want to be there. But I don't think it needs a lot, so we'll just put a little drop on top. Eventually, if it comes out. So I wasn't able to find my Kapton tape. I just found my aluminum tape, but I think would work temporarily or maybe permanently. I don't know, but that's pretty much what I did. Is I made a strip that goes from here all the way across, and then I put another cross strip to prevent it from lifting on both sides, so this stays down. This was more likely heating up because this wasn't really turning off the heater. Very likely that's what it was. If you can remember how it was before, it was just lifted pretty much almost like a 30 to a 45 degree angle. But yeah, let's close this up and then move on. Well, as of June of 2023, I guess they provide metal plugs. Maybe the whole thing was made of plastic and melted, aside from the thermal switch overheating the not triggering. This is now metal, so Don't see problems with that. And since it's not going to be overheating, maybe we're not going to have problems with this either. One thing I probably should mention, I didn't see any reverse polarity protection on this, so do not mix the leads on here. It wouldn't be that hard to put reverse polarity protection. This just be a diode rated for whatever this is rated for. I think it's 5 amps, 12 volts. So not sure why they just didn't put the diode in line with, I don't know, would be better on the negative side. This is the pump I'm going to be using. All this is a little motor back here. Oh, it's connected to something. Yeah. I wanted to use the screen. It would have been pretty cool to see some kind of data. I don't know what this measures. I know it measures pressure, but like it goes to the hundreds. I don't know what the units are. DIA, millimeters. Oh, mercury. That is actually useful. Anyways, we're not gonna use this unit. We're just gonna take the motor out from here. Unless I could somehow keep this always on, I would have to look inside here, remove these tabs, and see how I can bypass and keep the screen always on and then always reading. Other than that, we're just gonna get the motor. This is pretty cool. It has a solenoid bleed valve. I don't know what to call it. This connects to this little sensor that reads the pressure. So one of the problems we are going to face is that this is a 6 volt motor, not a 12 volt. This is a 12 volt supply. This is 6 volts motor, so we're going to need a voltage regulator or some kind. I don't even know if I have any. I'm just going to wire a switch directly to this motor. Just to get the proof of concept out of the way. I gotta find a way to connect this and then this to that little hose right there. I mean, I thought of, this to that and to this. So like this. Thing's huge though. Look how huge. It's massive. Okay, so I guess we're gonna have to look at something. Oh, look, this one. It's an end. This one fits, right? Oh, yes. Found this nice, beautiful toggle switch from Radio Shack. Remember Radio Shack used to be a thing? Damn. So I forgot to mention that this solenoid the valve is normally open. So when there's no voltage here, this will leak all the air that's here. So the motor and the solenoid need to be powered together to this switch, to this battery. Yeah. And there you go. This is pretty much how it's set up. That's all it is. I just gotta plug the hose to here and then from here to here. There's one concern because this is wired directly to that solenoid. I don't know if that solenoid has a type of resistor to prevent overcharging the coils. I checked the circuit board, and there is no resistor right here. So this 0 is a short, and then these two are 35 and 34 are to control this. Oh, damn, I can't hold this straight. It's to control this transistor. I don't know if it's a transistor. I know it's a transistor, but not the type. So NPN or PNP or one of the other types. So I don't think we have to worry about it, but it's directly wired to that coil. The motor's directly wired to that coil. That's what they're in parallel to the switch to the batteries in the back. Let's see it airflow. That's definitely more than enough power. So the last thing to do is to put a pressure switch inside that detects a certain PSI, say like 10 pounds of pressure or maybe 5, I'm not sure. And it'll electronically turn this motor off or just disconnect the batteries, pretty much what this does. We're going to hook it up in series, controlling the negative. That's what the switch is doing. It's just controlling the on and off the negative. That pressure switch is going to pretty much just self-regulate the pressure that goes in here. I'm not entirely sure how much pressure this pump is capable of, but it's just constantly on, and then that's something I don't want. Who knows what pressure it reaches. So that's the last step. I don't have a pressure switch, PSI switch, I don't know what they're called, but yeah, that's gonna be another day.